Welcome, welcome. We're going to talk through 219 and 220, and I can't tell you how excited I am. This is the end of the next to last packet. Let's do it. 219, I'm hoping a lot of people got this right. I think most of us did, but let's take a look. So a random sample of 432 people revealed that 100 are in favor of a certain bond issue. So this is a yes or no. Are you in favor, yes or no? So definitely a proportion question. So in the sample proportion, it looks like we asked 432 people and 100 people revealed yes. So that's 100 successes and 332 failures. Now, they performed a 95% confidence interval. So I actually need to divide this to get my point estimates. This is called a point estimate. We talked about this in the last question. My point estimate is 0.231. And so notice I can already eliminate A, B, C, and D because my point estimate has to be my sample proportion. Okay? So my sample proportion, so about 23% of people said yes, they're in favor of this bond issue. And I'm going to do a 95% confidence interval. And if I calculated it by hand without the calculator, which would be the proper one? So I'm looking at this here, and again, just using the formula, this is my margin of error, both numbers, and that's calculated by the critical value times the standard deviation of the statistic, which should be your p hat times 1 minus p hat over n. Then take the square root of the whole thing. So you're really trying to figure out, okay, yep, you see where that 2.31 and 1 minus p hat, that's just 1 minus 0.231. So that's where they got that 7.769. Then we look at that and say to yourself, yep, that's in. So that's where they got that number. The critical value is the only difference here. So that's really what I have to look up. And you got to know how to do this on a table. So you're scanning on in your table. This is table B. And you notice we're doing a 95% confidence interval. And so since it's a proportion question, we're not really fumbling around with this degree of freedom up top. We're looking here at the bottom and we notice it's 1.96. 1.96. So 1.96 is the critical value from table B for a 95% confidence interval. So that we're going to cast a net about 2 standard deviations from the mean in order to capture about 95% of the data. And that should make sense, and that's why this is my answer. Now, it is probably important to point out that 1.645 didn't come from nowhere. 1.645 is the critical value if you look at table B for 90%. So, if this problem was changed from 95 to 90, E would have been correct. Now let's take a look at 220. It states the commute time for a student to travel from home to a college campus is normally distributed with a mean of 30 and a standard deviation of 5. So this seems like a reasonable example. A student on average takes about a half an hour to get to campus, plus or minus, a typical student, plus or minus 5 minutes. Now it states if the student leaves home at 8:25, so let's write 8:25 here, what is the probability that the student will arrive on campus later than 9? So let's calculate what that travel time would be. To subtract time, this ends up being 35 minutes. I don't know if you guys are very familiar with doing math, but you could convert 9 o'clock to 8 o'clock and 60 minutes and merely subtract here, and that's how we can get 35 minutes. And so 35 minutes is actually exactly 1 standard deviation above the mean. And I can actually use the 68, 95, 99.7 rule to approximate this. I don't actually really need a fancy calculator, but I think most students would use the fancy calculator. So using, though, this rule, because I think it's really great to review that, 68%, if something is approximately normal, 68% is within one standard deviation. That'd be 34 to the left, 34 to the right. So notice also that half the information's to the left and half of the information's to the right. So this number is 16. 16% of the data is from one standard deviation continuing to the left, and 16% of the data is one standard deviation above continuing to the right. And ultimately, that's what they're asking of us. But let's go ahead and do this. If you had to use the fancy calculator and you had forgotten this rule. So I can do a normal CDF in my calculator, and I'll show you guys how to do that by taking, if I know the lower bound, the upper bound, mu, and the standard deviation. So I can calculate the area under this curve, which is the probability, if I know the lower bound. So here in my picture, it's 35. The upper bound, I'm just gonna use a really, really big number, and mu is 30, and the standard deviation's 5. And ultimately, I get a number that would round to that number as well. So I'm gonna go ahead and show you how to do that. Turning on my calculator. Making sure you guys can see the screen pretty good. So I'm going to do menu, statistics, distribution, because it is normally distributed, normal CDF. My lower bound I said was 35. My upper bound, I wanted a really big number. Mu is 30, standard deviation 5. Hit OK, bada boom, bada bing. That number definitely rounds to 0.16. Thank you for joining us. We're getting close to the finish line. Woohoo!